now we shall move on to the next problem, which goes like this. Problem number 4. Determine the centroid of the section of the concrete dam as shown in figure. So here they have asked you to find the centroid of the cross section, which is the section of the dam, concrete dam. So that looks like this. And the dimensions are this is 6 meters and this is 1.5 meters. And this is 5 meters and this is 1 meter. So now we need to locate the centroid of this particular component, that is the section of the concrete dam. So where exactly will the centroid will be lying? So you cannot say, you can just plot it approximately somewhere in between. We can plot the centroid, but where exactly, that has to be calculated. So what is the procedure? The first step says we have to look into the axis of symmetry, if any. Do you have any axis of symmetry? No, we cannot draw any axis of symmetry here. And then the second step will be so drawing the reference axis or the coordinate axis and placing this figure inside that particular reference axis. So we need to draw the reference axis, and then this is a section. Here you don't have the regular geometrical figures. The shapes are not the regular geometrical figure. So these are to be divided into number of known components. That is, you know, the rectangle, triangle, circle, semicircle, etc. You need to divide these components so that you know the centroidal values of those individual components. So how can you divide the components? So what I can do here, first let me write the reference axis. Let me choose this as origin and let this be OX axis and let this be OY axis. Then how do you divide this? See, what way I can do, if I project the lines like this, this part will now become a right angle triangle, and we know the centroid of a right angle triangle. Then if I just project the lines like this part will be now looking like a rectangle. Then if I draw a line and join this, this will be a separate triangle and this will be a separate rectangle whose centroidal values are known. That is from the derivation part. Okay. So, how many components are there totally? So, 1, 2, 3, 4. So, there are totally 4 components of this particular section. So, let me number it. So, this will be say component 1, component 2, component 3 and this will be component 4. Okay, now first step is you need to locate the centroids of individual components. Then put that individual component on the reference axis or the coordinate axis, then measure it with respect to OX and OY axis. Okay. So, now we have 4 different components. Let us take it one by one. So, first component 1. What is component 1? I shall mark the boundaries. Let me name the boundaries A, B, C, D, E, it is O, F, G is used for centroid. So, H, I, J. See, now the corners are marked. Now, component 1 is a right angle triangle. So, let me write the same figure. This is E, O and D. What is the base of the triangle? 2 meters. Height of the triangle? 6 meters. This is the dimensions given. Now, how do you locate the centroid of a right angle triangle? So, we know the centroid of this right angle triangle lies here. Distances are, if you measure it, it will be B by 3 and the remaining will be 2B by 3. This is the values known from the derivation. So, we have already derived these values. Okay, this is for the x axis, x direction. What about y? So, with respect to this and this, so with respect to the base, we can write this as h by 3 and the remaining will be written as 2h by 3. So, it all depends on from which point we are measuring. So, what is the reference axis which we are considering? From that axis we need to measure it. See, I have marked the centroidal distance from various points. So, that all is very much important when we consider the reference axis. Okay. So, I have written all the possible scenarios for a right angle triangle. Based on your reference axis and the requirement, you need to determine it from either this end or this end. Okay. So, now let me write only. So, now let me write it clearly. This is O, D, E, this is 2 meters, 6 meters. If I locate the centroid here, so this will be its x and this will be its y. Okay. So, area of triangle A1 component 1 half into base into height, which is 6 meter square. And what about the x component of this triangle, right angle triangle, which I am measuring from this end? It is x is equal to b by 3 base is 2, 2 by 3 is in decimals 0.667, for timing let it be 2 by 3 itself, and y is given by h by 3, the height of the triangle is 6 meters, 6 by 3 is 2 meters, and this be 0.67 meters. Clear? This is for the individual component of triangle. Now if you plot it here, measure it with respect to the reference axis, you need to plot the x1 and y1 values, x1 from OY and y1 from OX. So when we write the table, you will be understanding that neatly. So this is with respect to component 1. Similarly, component 2. What is component 2? It is a rectangle. So rectangle A, B, C, D, it is 2 meters by overall is 7.5. So where is the centroid of this rectangle lying? It is exactly at center. So this will be the x component and this will be the y component. So A2 x2 into 7.5, which is equal to 15 meters square, and x is equal to half of 2, 2 by 2, 1 meter, y is equal to half of 7.5, 3.75 meters. This is the centroidal values of only the individual component number 2, but you have to measure it with respect to the reference axis or the coordinate axis. Okay, this is component 1, component 2. Now let me write component 3 and 4. So what is component 3? It is a triangle. So right angle triangle F H say K, and this base is 3 meters, height is 5 meters. So where does this centroid lie? For this triangle, the centroid lies here, and this will be what? X, this will be what? Y. So from the derivations, we know x and y of a right angle triangle. So now let us write A3, which is component 3, which is equal to half into base into height, that is 15 by 2, 7.5 meter square. What about x? You are measuring from this end, it is b by 3. So b by 3 is base, 3 by 3 is 1 meter, and what about y? It is h by 3, that is h is 5 by 3, it is equal to 1.67. Now component 4. It is a rectangle of size 4 meters by 1 meter, and the naming K, I, J, C. Where does the centroid lie? Here. So the individual x of this and individual y of this, that is the area A4 is given by 4 into 1, 4 meter square, and x is given by 4 by 2, which is 2 meters, y is given as 1 by 2, which is 0.5 meters. See, again you could have written the table directly, and since we are dealing with the triangles for the very first time, I have written this component separately and marked the centroids separately. Okay. So as you practice and practice, you can be thorough with these things, and then you can directly write the table. Okay, if you follow my suggestion, please go with this thing. Write the individual components separately, then try to fit it inside the reference axis and then measure it with respect to OX and OY. Okay. Now let me write the table. Component area. See, you might have made a habit of writing mm square everywhere. Please look at the units carefully. Here it is in terms of meters. So the area is expressed in terms of meters. Next, write x bar in meters with respect to OY axis. Write y bar in meters with respect to OX axis. So how many components are there totally? Let me divide this into 4 components. So first component is a triangle EDO, right angle triangle, and the area which I had already calculated, half into 2 into 6, that is area is 6 meters square, and then x1 should be measured with respect to the reference axis. So we had calculated it from this end, am I right? But you need to calculate it from this end, that is with respect to the referral axis. So this is the value which you know from the previous step, but I need to calculate this from this end. This is our x1 value. So we had written the x value from the previous step as b by 3, it is 2 by 3, am I right? 2 by 3. X was written as base by 3. What is base? 2 meters. If the base is 2 meters, we had written it as 2 by 3. Now if you want to write it as 2b by 3, that is 2 into 2 by 3. Okay. So because we are measuring it from this end, the values which I had written in the beginning itself was 2b by 3. This is b by 3 and 2 is 2b by 3. So you had written this value, but I need to measure it from OY axis. That's why it should be written as 2 into base by 3, 2b by 3, which is equal to 4 by 3, which is equal to 1.33 meters. And coming to y1, this will be equal to y1. So what is y1 equal to? H by 3. So you can easily write that y1 equals to height of that triangle is 6 by 3 is 2. y1 is 2 meters. First component is over. Now let us try to write the second component. Second component is a rectangle AB CD. So the orientation like this. Area 2 into 7.5, which is 15 meters square. And what about x2? It should be measured with respect to OY axis. So with respect to OY, try to locate its centroid. So this is for the individual component from here to here. It is x2. How do you calculate x2? See, from this point to this point it is 2 meters plus 2 by 2. 2 plus 2 by 2, which is equal to 2 plus 1, 3 meters. Similarly, plot y2. So reference axis OX to the centroid of this component is called as y2, and that is given as 7.5 by 2, which is equal to 3.75 meters. Now second component is over. Coming to the third component, HK. So it is a right angle triangle. Then write its area, half into base into height. So half into base 3 meters into height 5 meters. So it is 7.5 meter square. It is half into 3 is 1.5, 1.5 into 5, 7.5, and then x3. See, you had marked the centroid at this point for this component and you had written this as b by 3, but you need to measure it from the reference axis. This is to be measured as x3. So you know this distance. So it is b by 3, 3 by 3 is 1. Okay. So that is this distance. This is 1. From this line, reference axis OY, from here to here it is 2 meters. Here to here it is 4 meters plus 1. 2 plus 2 plus 3 by 3. It is 2 plus 2 plus 3 by 3, b by 3, which is equal to 2 plus 2, 4 plus 1, 5. x3 is 5 meters and corresponding y3 with respect to the referral axis. The individual component y from this base, which is h by 3, which is nothing but 5 by 3. 1 plus 5 by 3. 5 by 3 is nothing but 1.67 plus 1 will be equal to 2.67 meters. And the last component, component 4, is KIJC, rectangle. Area is 3 plus 1, 4 meters, 4 by 1. It is again 4 meters square, and x4 is equal to, see, only for this rectangle you had plotted the x value, but you need to measure it from the reference axis here. So this will be x4. So the total distance from this point to this point is equal to 2 plus 2, 4. We have reached this point, plus 3 plus 1, 4 by 2. 4 plus 4 by 2. That is, let me write 2 plus 2 plus 4 by 2. So 2 plus 2 plus 2, 6 meters is x4. And what about y4? This is y4. So this is again half of the 1 meter. That is, y4 equals to 1 by 2. That is equal to 0.5 meters. Okay. Now you have arrived almost at the end. The only thing which is remaining is calculation of x bar and y bar using the formulas. That is, x bar is equal to a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 divided by a1 plus a2 plus a3 plus a4. So substitute corresponding values here. That is nothing but a1 is 6 into x1 is 1.33 plus 15 into 3 plus 7.5 into 5 plus 4 into 6 whole divided by 6 plus 15 plus 7.5 plus 4, which is equal to 3.52. So x bar is equal to 3.52 meters. Similarly, if we want to calculate y bar, so the y bar is given by a1 y1, a2 y2, a3 y3, a4 y4. That is So what is y1? y1 is 2, y2 is 3.75, y3 is 2.67 and y4 is 0.5. After calculating, we will be getting it as 2.78 meters. Okay, so x bar is equal to 3.52 and y bar is equal to 2.78. So now, after we have calculated x bar and y bar, the final step should be written in the form of, therefore g of x bar comma y bar is given by 3.52 comma 2.78. So these are the coordinates of the centroid of this entire lamina, coordinates of the centroid. So using this you can plot it. So 3.52 is x, y is 2.78. Somewhere around here you can locate this point as g of x bar comma y bar and draw the centroidal axis as xx and x axis yy. So what are the values of g? 3.52 and 2.78. So again, even if you change the reference axis, the location of centroid will not be changing. Okay, the coordinates values might be changed. That might be having the different numbers, but the location will be at the same point. So this is how you take up a problem consisting of triangle section, rectangular section, again triangle and a rectangle. So in the coming sessions, we shall take up problems consisting of different shapes. In a single problem, we will be having a triangular form, circular form and the rectangle. So in a single problem, it is a composite section. We need to divide those components into different shapes whose centroidal formulas are known to you. Okay, so we shall meet in the next session. Thank you.